In this clip, we're going to calculate the pressure head at this predefined point X, we're calling it. So if you look at your sketch, X is 6 centimeters over, 6 centimeters above the datum here, and we're gonna use your flow net to calculate the pressure head at X. And when you calculate the pressure head at some point, typically we use that to calculate uplift forces, uplift pressures, and then uplift forces. For the moment, we're just gonna use this to calculate the pressure head at this one point. Everybody's pressure head calculation might be slightly different because everybody's flow net is slightly different, but they should all be pretty close. And after we calculate the pressure head at X, we're gonna take the piezometer, so this open-ended tube, we're gonna insert it down inside the sand, so it bottoms out at point X. So I scaled this off, 6 centimeters and so on. We'll bottom it out at point X, and we'll measure with the meter stick the vertical rise of the water here, and that is by definition the pressure head. So we'll see how close that is to the calculation. Hopefully it's fairly close. The process to measure the pressure head at X. So the way this is going to work is as the water flows through the system, it's going to lose energy. It takes energy to force the water through. And how much energy is lost? Well, we know that the head loss across the system is 15 centimeters. And if we want to kind of break that down and how much head loss occurs for each one of our equal potential drops, we can do that. So what we're going to calculate is called the loss per drop. So the head loss across the entire system, we divide that by the number of drops. We have 15 centimeter head loss across the system. We have a total of 6 drops. So that means we lose 2.5 centimeters of energy of total head for each drop. So over here, let's just confirm we have those 6 drops. This is an equal potential line. We travel from this line to that line, that's 1 drop, 2 drops, 3 drops, 4 drops, 5 drops. And then back up to here, that's an equal potential line as well, that's 6 drops. Okay, and so for each time the water travels from one equal potential to the next, we just calculated 2.5 centimeters. So boom, 2.5 centimeters gone. Takes another 2.5 centimeters of energy to get to here, and then another 2.5 centimeters to get to here, and so on. Okay, so the strategy we're going to use to calculate the pressure head at X is we're going to start at point A, where we have a known total head, namely the elevation head plus the pressure head. The total head at A for us happens to be 38.5 centimeters. So we're going to start at point A, and we're going to count how many drops does it take to get over to point X. So your value of the number of drops it takes to get over to point X might be different than somebody else because your flow nets are drawn slightly differently. And point X may or may not line up right on an equal potential line. If it's not exactly on an equal potential line, just interpolate where it is between 2 equal potentials. So it could be whatever it is, like it could be like for mine, I have 1, 2, 3, it's almost 4 because we're not quite up to this equal potential, so I might say it's 3.9. Okay, so you kind of prorate or interpolate how many drops it is from this equal potential all the way down to point X. So this is, we're calling the head up at this equal potential. We could say that's point A. So this is kind of the way we're going to do this. Assess the total head at A. Well, we just did that. Count how many drops it takes to get from A to X, and prorate if it's not exactly right on one of the equal potentials. And then calculate how much total head do we lose for the water to travel from point A to X. Well, the total head at X is going to be whatever the total head is at A. So this is going to be equal to the total head at A, right? You start off with some head, and then how many drops, you calculate how many drops it takes to go from A to X. We multiply by the head loss per drop, and that's going to be how much energy it takes for the water to travel over to point X. So then we can, so now we know the total head at X. The elevation head at X, well, the point X was given at 6 centimeters. So by knowing the elevation head at X and the total head at X, then we can just use Bernoulli to take the total head minus the elevation head equals the pressure head at X. Okay, so that's the basic strategy for calculating the pressure head at any point in any flow net. And so you might do some problems like that in some lecture problems. And then you might take those pressure heads, convert those to pressures, and then calculate uplift forces. So that's usually what we do with this. So we're gonna go ahead and now measure the pressure headed X. So I'm just gonna kind of push the piezometer into, I'm trying to see if it's at the point X. Yeah, there it is at point X. And I don't know if you can capture this on the video, but right there in the tube, you can see the water level is just kind of coming up to equilibrium. It's kind of creeping up. And is it gonna pass this level? Tell me your answer quick. Think to yourself, is it gonna stop right there? Is it gonna keep going? It looks like it's going to, it's gotta keep going, right? Because we have to have energy to push the water up to that level. So we have to have more energy down here than we have up here. So, there we go. We got a few bubbles. But you can see it's still, now that it's right up here, it's still kind of rising up. There it is. So this might just take a moment for the water level to rise all the way up to the pressure headed X, and then I'm gonna go ahead and measure that. Yeah, you can keep going. Yeah, we can just keep videoing. So I'm just gonna watch that. So, let's see. I don't believe we have a spot for this on the data sheet, but you're going to calculate the value. We're going to measure it, and in the report, you're going to compare the two. Hopefully, they're pretty close. It'll make us feel a lot more confident about flow nets. I'm just watching it to see if it's stabilized the water level in the piezometer. It's clear up to here. So I'm measuring from where the bottom of the tube up to the water level. And it's almost, it looks like it's right at 21 centimeters. All right, so we're gonna go with that. So let's see. Our measured pressure headed X was 21 centimeters. You guys calculate the pressure head based on your own flow net.